Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about teaching volume. In this video I'm going to explain the similarities and differences between volume and capacity. I'll talk about different units of volumes. We'll look at finding volumes of cuboids, and I'll cover isometric drawings and making sure children understand them. And finally, I'll compare and contrast measuring in 1, 2 and 3 dimensions, which is a really important thing to cover with your children. Before you cover this topic, it's a really good idea if you've done some work on 3-dimensional shape with your children. So here's a link to that video now if you've not seen it. Okay, let's get started. So the first thing teachers need to understand is the similarities and differences between capacity and volume. So to put it quite simply, this 3-dimensional shape has volume. It fills 3D space, and the volume is the amount of 3D space it fills. But it has no capacity because you can't put anything inside it. So this bit of Dean's apparatus has volume but no capacity, and this container has capacity and very little volume because its sides are quite narrow, although it does have a little bit of volume. And the capacity of this container happens to be very similar to the volume of this shape. Primary school curriculums often aren't particularly fussy about the precise use of capacity and volume, but it's really good if you as a teacher understand it. So hopefully that makes good sense now. Right, let's talk a little bit about units of volume. So we're going to need some consistent units for counting volume, and the most common one that we use is the cubic centimetre, centimetre cubed, which happens to be a unit of Dean's apparatus or base 10 apparatus. Every edge on this cube is 1 centimetre, and it is a centimetre cubed, or a centimetre cube, or a cubic centimetre, or cm with a superscripted 3. And it's just best if children become familiar with all that vocabulary. The key is to have a really clear hook in their imagination. They need to touch and feel what a cubic centimetre is, and then all of that vocabulary will just attach itself to that multisensorial model in their imagination. So the volume of this bit of Dean's apparatus is 10 centimetres cubed. This one is 100 centimetres cubed. And the one I was just showing you is 1,000 centimetres cubed. But when we measured capacity, it tends to be measured in millilitres and litres rather than cubic centimetres. In fact, it turns out that the volume of this is 1 litre. And the capacity of this is also 1 litre. Now there are 1,000 millilitres in a litre, so 1 cubic centimetre is also 1 millilitre. And it's best to imagine that in ice. If this melted, you'd get 1 millilitre of water. Its volume would remain the same. But it's just that we usually link millilitres to liquid volume rather than to solid volume. But we don't have to. They are the same thing. So just to be totally clear about what I'm saying here, I am saying that if you had 5 cubic centimetres of ice and you melted them, they would exactly fill this teaspoon measure, which is 5 millilitres. Now, it certainly doesn't look like they will if you try to put them in solid. They quickly fill more than the teaspoon, but it is the case. And I'll come back to that in the video on capacity if you want to see a little more about that. Let's talk a little bit about our units of volume. We've already met the cubic centimetre, which is written as cm with a superscripted 3. And of course there's the cubic metre, which is written like that. And we came across that in the video on large numbers where we tried to imagine how many cubic centimetres there'd be in a cubic metre when we were just talking about it as Dean's apparatus. So here's a link to that video now if you'd like to link the topic of volume to your exploration of large numbers. And if you're talking about the atmosphere or the volume of the Earth, we could talk about cubic kilometres. But most of your work at primary school level is about cubic centimetres. And as I've just said, 1 cubic centimetre is the same as 1 millilitre. Right. Now children need to be able to find the volumes of simple shapes, And the biggest mistake a teacher can make is to download a worksheet on this and ask children to work from a worksheet without actually building anything. So you might find something like this and ask children to puzzle out the volumes of these cuboids. Now, some children really struggle to see what on earth is going on here. If this pops into 3 dimensions for you, then you don't realise how difficult it is for a child that does not happen for. So don't start like that. Dig out your Dean's apparatus, dig out your base 10 apparatus like this and ask children to build you different cuboids with volumes of 20 centimetres cubed and so on. So they really get a multi-sensorial understanding of what volume is and what cuboids look like in 3 dimensions. So if you set them that task of building a cuboid with a volume of 20 cubic centimetres, they might come back to you with something like this. This cuboid, you can see, is 2 centimetres high, 2 centimetres wide and 5 centimetres long. I then recommend that you print off some isometric dot paper, which I found easily on the internet this morning, free to download. This is what it looks like. It's dotty paper with 1 centimetre triangles with dots at every corner of the triangles, every vertex of the triangles. To use this paper, you need to use it so that you have vertical lines of dots. If I turn it this way, you don't get vertical lines of dots that are 1 centimetre apart, so it's not going to work. Has to be this way. So for the cuboids that I just built, it was 2 centimetres high. So we draw the height with a single line. It was 2 centimetres wide. So we go 2 centimetres in one upwards diagonal direction, and it was 5 centimetres long. So we'll go 5 that way. And then we just add in the other lines like that. And we can start to add in the finer lines that show where this individual centimetres cubes are. And that now looks like what we've just built. And children can begin to connect those diagrams to their models. And it's a really good idea to teach them to draw these themselves. If you go at it slowly, you can. You need to get your isometric dotty paper the right way round. You need to draw a line for the height, and then a diagonal line for the width and a diagonal line for the length. And then if you show them what you do next and they help each other out, they should be able to get there, draw different cuboids, and then gradually you can show them pictures of different cuboids, ask them to build them and ask them to find the volume the other way round, and they will all now deeply understand what's going on. And if you get them going with isometric drawing, there's lots you can do with that, and you can extend the day into an art lesson in the afternoon. Give them the chance to experiment with isometric drawing, colouring the front faces in one colour, the side faces in another colour, the top faces in another colour. It's a great topic. Who would want to miss this? But I should warn you that when you come to exam practice, no matter how much you've done it, some children will still struggle to decode pictures like this in their imagination. Now, if you've done the practical work, you should be able to sort that out really quickly. But if your children are going to face questions like these, you will need to do some of them in practice tests at a time when they've not built anything recently. The final part of being an expert teacher of volume is about teaching your children to deeply understand the difference between measurements in 1, 2 and 3 dimensions. So one way of doing that is just to give them some units of measure and ask them which of these are for length, which are for area and which are for volume. And you will find that you can't use a measure for length to measure area, and you can't use a measure for area to measure volume, because area is flat, and however much flat shape you measure, you never get a 3-dimensional solid measure. So it's great to talk about that. It's great to talk about one dimension just goes in one direction. Where you've got a 2 in a measure, it's going 2 ways, so it's area. Where you've got a 3 in a measure, it's going forwards, sideways and up, so you can get anywhere in 3-dimensional space. And then I've just chucked in millilitres as a googly because that is a 3-dimensional measure. The exception that proves the rule. And when your children have become really fluent at understanding and decoding these diagrams, it's a really good idea to recap the topic of surface area. Remember, you can get children to build these with cubes and then wrap them up in squared paper to see how much wrapping paper is needed for them. So you can talk about volume, surface area, and the length, width and height of a cuboid at the same time. So you're exploring 1, 2 and 3 dimensional measures together. Now, in general, I only recommend apparatus that's really cheap or you really should have in the maths classroom, like bead strings and some Dean's apparatus and some place value counters. I made an exception for my magnetic polydron, and I'm going to make one more exception now because this film is absolutely awesome. I just can't recommend it highly enough. Now, it's quite hard to get hold of at the minute unless you've got DVD players in your school, which you may well not have. At the minute, there doesn't seem to be an easy streaming option on the site of the producers who made this. It's called Flatland, and it's a film that really brings to life 1, 2 and 3 dimensions and touches on the reality of a 4th spatial dimension, which is required for all the maths that underpins electricity and all sorts of higher level maths that we use in everyday life. But we don't talk about the fact that that maths relies on there being a 4th spatial dimension, which is just mind-boggling. This is a beautiful, beautiful film. It's about 40 minutes, I think, and it will have your whole class and you totally captivated, and you'll want to watch it several times. And it's completely inclusive from 2-year-olds to 100-year-olds. Everybody loves it. Just blows your mind and makes the most difficult ideas in maths accessible to everyone. So if you wanted a class of children who are absolutely inspired to go on and study maths at the highest levels, this is awesome. And once I put it in this video, I'll contact the makers and tell them, look, it's in this video. How do people download it for a reasonable charge to show their schools? And hopefully they'll find a way, and I'll put that in the description of the video if I find one. So in summary, in this video, we have covered the similarities and differences between volume and capacity. We've talked about units of volume, and we've explored finding volumes of cuboids, the importance of building them and getting children to understand 2-dimensional isometric drawings of 3-dimensional shapes. And finally, I've talked about the importance of ensuring every child develops a really clear understanding of the differences between 1-dimensional, 2-dimensional and 3-dimensional measures. Thank you so much for the time that you're investing in becoming a fabulous teacher. If you'd like to see more of the videos, you can see a full list with links to every video at www.authenticmaths.co.uk/videos. Hope you enjoy your teaching. If you've any comments or thoughts, please leave comments underneath this video. And if you've not yet subscribed to the channel, if you could do that, you'll be able to find it again. Enjoy your teaching. Bye for now.